Okay, just going to wait a couple moments here for folks to catch in. Okay. Wow, we've got a couple of viewers. Welcome. All right, let's get this show on the road. Greetings, tech art fans from around the world. Welcome. It is 12 o'clock, a little half hour usually than where we usually show up. It's 12 o'clock, and this is time for Tech Art Talk with Tech Art Talk Live with me. I'm Chris. I am your host for today's session, and you'll have to excuse me if I'm a little bit frazzled. There's a lot of stuff going on right now. From the great immortal words of Buckaroo Banzai, who once said, "The only reason for time is so that everything doesn't happen at once." Horsepucky. I don't know. I think the only reason for time is so that everything does happen all at once, or so it seems. Anyway, that's my rant for the day. But anyway, welcome. We are now in the 6th or the 7th week of my Python immersion course. I can't remember which. We took a little bit longer to go dealing with the separate topics of Python exceptions. And this is the second part of that, Python serialization. Okay, and now this is an important lecture because what we're dealing with is using Python to import and to export just buttloads of data. We can't like have just typing in stuff. We have to do is get output buku amount of information. Now, whether it's going into UE4 or Unity or some other engine or who knows what, or it's bringing in maybe USG data or something with maps and other such things. Who knows where that data is coming from? But anyway, this is how you do it. This is how you get Python talking with the rest of the world. So without further ado, let's get things rolling with Python serialization. Okay, now calling here everything but the pickle. Actually, this is not everything. This is just a subset, and we're not going to be talking about pickling. Now there is a serialization technique called pickling, but I'm not going to focus on that because very few, only programmers do the pickling anymore. I don't know who else does it anymore. But here is the basic stink. This is I think you got to keep a focus of. It's actually very simple to deal with external files in Python. In fact, it's brain dead simple. Everyone's afraid, oh, I don't want to deal with external files. It's too crazy. It's too heavy. It's actually a lot simpler than you think, because the idea is that you either want to import or you're going to export just one big fat monster string, and that big fat monster string has all the contents of the data that you're going to be dealing with. You're going to dealing with the whole thing. Now, unless you're actually dealing with binary data, which I don't know, some people do, some people don't anymore. It really depends. But disk space is not the heavy resource that it used to be. And now memory is available, and you can pretty much bring everything into your Python session as just one big old string. And so start getting into the habit of just bringing in your entire Python file as one big fat monster string. Or if you're going to write out anything to file, just put the whole thing into one big fat uber string and then export that one string file. And that's really all you got to deal with is it's just one write and one read. And we see, is it really that easy? Well, yeah, technically it is. Now things get a little bit more interesting when you're dealing with certain file types. Now I go on with two file types demonstrated in this lecture, and we're dealing with JSON and XML. These are the two file types that you're most probably going to be dealing with as a tech artist. Now, there are other formats that you can use. In fact, there's an infinite number of other formats that you could be using. But in general, most of the time, you're going to see JSON and XML data. All right, so here is the basic functionality. And it's really just three steps. And I know it says 4, but really 2 and 3 are kind of concatenated together. So first step number 1, you're going to open up the file. And then step number 2, then you're either going to read all the data from that file and cram it into a string, or you're going to take a string you have in your Python script, and then you're going to just shove it right into the file again. The whole one big fat string. Once you finish either done reading or writing, then what you're going to do is close the file. So it's those 3 steps. Open a file, do something with it, either read or write data to it, and then you're going to close the file. Those 3 things. And that's really all that serialization in Python is. Now, I realize that I'm oversimplifying things, but a lot of times from a tech artist perspective, you got to oversimplify things because you've got a million things going on. Most probably there are fires going on. You realize, okay, how are we going to deal with this? Okay, real quick, we got to do this. So think of only 3 steps. Open, do something, close. Very simple. All right, so I'm going to go right on here. So here are all the Tech Art Talk Live topics that we've gone over for the last year. There's 36 of them. And suppose what we want to do if this was all written out to a text file. How would we actually deal with this if we wanted to bring this into our Houdini session? So let's take a look at an example script of what that would look like. Okay, so here it is. I've got the script already created here. I'm not going to futz around with trying to recreate the script. I've got the script already created here. And can this get a little bit bigger? No, I don't think so. Apologies. So it's always wise to use a try when opening up a file. It's very possible that when you try to open up a file, either that file doesn't exist or you don't have write permissions or something goes along that happen. That's why it's usually a good idea to use a try. Now, technically, you don't have to. It's just that if you don't use a try, you could potentially leave certain assets hanging and open. You could create a zombie process, but let's not go into that for right now. Just it's good practice to use a try. I'm just going to leave it at that, but it's not necessary. So in the first statement here, we're going to try in file equals open. Open is your magical statement. And then inside the open statement, you have the name of the file. And then you have a little enum that you are invoking here that does one of 2 things. So you're going to either read, you're going to write, or you're going to do some kind of combination for them. Maybe you're going to read and write. I don't know. Depends on the context of you're going to be using. I don't know. But here it is. You're going to open the file. So it's just open. And then the name of the file. And then what are you going to do with this file? You're going to read, you're going to write, whatever. And you're going to assign this. And this is called a file pointer, because this actually becomes the actual file. It's the essence of the file. And then here we have the except in here. So if something happens and it doesn't open, then you're going to raise an IO error. But here, else, this is where it all comes in. So once you have the file that's open, you do statement number 2. You're going to read the contents. So here we go, TAs equals in file dot read, and that's all it is. There's no parameters, there's no nothing. You just say, okay, file, give me every frickin' thing that you've got, put it into one big old string, and put it into that TA variable. Okay, that's fine. That's all we're doing. And then we're going to go, okay, then we're going to close the in file that we opened. Now notice that close then becomes a method associated with the in-file object. And that's because a file pointer actually is a sufficient robust class inside of Python, and you could go in and noodle with it all day. Now, TAs typically don't do that, but you could if you want to. But one of the methods that you do use more than often is close. So that's step number 3. You close the file, and so therefore, boom, you're done with it. Now, in this situation, I'm going to, since it's coming in as just one big giant string, what I want to do is chop it up into lots of little strings. And then I want to create a for loop for those little strings. I want to go through all that sequence or the list of little strings, and I want to print them all out. And so if we try to execute this, we'd end up with something that looks like this. Okay. Now what I did, I read from file, I read in these 36 little objects right in there, right from the file, and then I printed them out. You see that was very fast and very simple. Just 3 steps here, folks. Okay. Okay, I'm going to get right back to my presentation here. I think this is it. Here we go. Excellent. Okay, now as a rule of thumb, in the old days where memory was a real big premium, programmers were more worried about reading in only one little chunk of data at a time. And that would save memory. So you really only deal with one thing at a time. Okay, you don't have to deal with that so much anymore because memory is now kind of like an uber premium, and the TAs, you have enough to do putting out fires, running around, helping animators, fixing textures, making characters work again, getting rid of, fixing faces that are exploding. Anyway, you don't need to deal with a lot of that subtle nuances of only reading and writing little bits and pieces. Just go ahead and just read the entire file contents into one just string. And then once you've got it into that string and you've closed off the file, then you can say, okay, no problem. Then you can go ahead and parse that string and look through that string into any way possible. And you could do it at your leisure. So you're not going to feel like, oh, I got to get those done quick because I've got the file open and I'm holding up resources. Humbug. Close the file as soon as you open it and read the data from it. You just close it right again, and then you've freed up that resource. Now, I have a hunch that that's going to become really important when people start working with USD. And then once you're creating dynamic USD files from Python scripts and so forth, that is going to be a big issue of holding resources hostage while you write into them. And treating the data like this will help eliminate some of that problem because really what you're going to be doing is opening and closing the file almost instantaneously. All right, here are the modes that you can use to that. Remember when I said that open statement and then the name of the file, and then there was a mode that we opened up the file? Here are the modes that are available. Typically, you're going to use R for reading, W for writing, or this is kind of like superfluous. You can use A for appending, but honestly, if you use W, the information that you put on it is going to truncate, and if it doesn't exist, it's going to create it. And so A does the same thing because it's kind of like it's a little bit redundant. Now, if you put in R+, then you can open it for reading and writing, but it will give an IO error if the file doesn't exist. Suppose like you want to read a file and you want to write from a file and you're expecting this file to exist. If the file doesn't exist, it will throw an IO error if it tries to open this up and it doesn't find it. Okay, on the flip side, you could use W+. W+ does the same thing. You can read to the file or write to the file. Doesn't matter which you want. And it truncates if the file exists already, but it doesn't throw an IO error if the file doesn't exist. If it doesn't exist, then it tries to create a brand new file. Now, if it fails creating the brand new file, then it's going to throw an IO error, but it's not going to throw an IO error if it wants to go ahead and create one if it doesn't exist. Okay, so but really keep it simple. Just worry about R for reading and W for writing. Not too difficult. All right, so let's take a look at what if we want to close the file. Let's take a look at what this would result with. I'm going to close this. Now, if we wanted to put into the fail, notice here we have a very, very simple little script. We're going to import the sys, and then we're trying to open gdwtf.py, and we want to read from it. Now, this isn't going to work. So this is why we put in the file.close, because if this file accidentally opens and we didn't want it to open and the file somehow crashes or the exception didn't work, then what this does is the file.close closes access to this file. And that means anyone can open it again. Now, have you ever been in a situation like if you had a file open in, let's just say Photoshop or Maya, and then you were working on another process and you wanted to access that file and Windows wouldn't let you, and because that file is open up in another file? Okay, well, that's because the resource of that file is only allocated, and some other process has that file pointer, and it says, "Ooh, I've got this file. I'm not going to let anyone have it until I'm done with it." Well, if the program crashes, or it stops, or it halts, or whatever, and that program still has that little file in its hands, guess what? It, no one can get a hold of it, ever. So what you say, well, geez, what happens? I mean, like, that means that the process or the file then becomes zombified. That means it lives on and it's held into infinitum until one of two things happen. Well, your computer or the world runs out of electricity, and the computer actually dies. Yeah, or you reset the computer. You recycle it. If that doesn't happen, guess what? That file is held and it is dead for that. I don't know how to resurrect a file pointer that is checked out. I suppose that it can be done, but my TI days are long over and I don't remember how to do it. I think there's is a way of resurrecting it using old Linux, but I'm not sure. But as you can see, what this does here in this file, if we try to open this file and it raises an IO error, you'll see that it just quickly fails. See, it says file could not be opened. I'll try to do it again. Yeah, and it just fails. And you see that even though it failed to open up the file, it didn't throw any kind of like obnoxious error. It just put a claim that file couldn't be opened. Even though the IO error had been raised, no big deal. Okay, suppose we wanted to write to a file. We had practice writing to a file. What are we going to do if we want reading to a file? What do we want to do is to write out a file? Okay, it's just really the same process. So for this, let's output crag. Okay, give me a crag. Okay, I know we're getting sick of Roberto there. Roberto's got too much of the spotlight. Time to let somebody else have the spotlight. We got crag here. Okay, so writing to a file is just as easy. So step one, we're going to open up the file, but instead of using the mode as R, we're going to use W for writing. Here we're going to handle any file errors that might happen. And now here's our else when we do this. We're first going to create a node that points to crag. And then we're going to use the command file.write. Instead of file.read, we're going to make file.write. Okay, what are we going to write? We are going to write this big old giant string. And where we're going to get that big giant string, we're just going to get crag, and we're going to turn crag into code. And this is the old Houdini way of saying crag.asCode recurse equals true. So basically what you're doing is you're converting the entire nodes, the network, the entire crag network into one big giant string. As code just turns it into one big giant string, and then we're going to write out that big giant string. And then once we've written it out, then we're going to close it right up again. So you might be saying, okay, it's a big giant string. Yeah, like how big is big? It's big. Take a look at this. Okay, all of this gobbledygook is what crag looks like when Houdini creates it. Look at all this garbage. This is a lot of stuff in here. Now, I realize that Houdini is just dotting its I's and crossing its T's, keeping things nice and orderly, but look, this is like nonsense. Okay, so let's go ahead and see if this works. We got to go ahead and execute this. And we're going to go click crag out. Oops. Houdini none has type. Oh, look at that. Okay, we've got an error, and this is because I forgot to change my name. It's because we're looking for obj/crag. Okay, that's not going to work, so let's go ahead and change that to crag. We have to use a capital C. Okay, now let's try to do this. Crag out. Okay, good. Then we have no problem. Okay, now how would we know that this actually works? What we can do here is, since we have this file opened up inside of our little text editor, what I'm going to do is I'm going to Control A to select the whole thing, Control C to copy it, and then I'm going to create a brand new tool, and let's call this Make Crag. Okay, we're going to make crag here. And then inside of the script, I am just going to paste everything that was in that. Okay. So that big old string is right here. So this is what got created here. I'm going to go ahead and click accept. And then I'm going to get rid of crag here. And so how do we know that this all worked? We're going to go ahead and press make crag. And then there's crag again. So that's really basically how simple it works. It really wasn't a whole lot of work in order to get this going. Okay, so like if we wanted to go in and read all of crag in, I got another little script here. If we just wanted to read it in and print it to the screen, once again, very, very simple. 3-step process. Go File, Open. We're going to open crag.py that we just wrote out. And we're going to open it for reading. Then we're going to raise an IO error in case something fails. And then here it is. I'm going to read from the file, and I'm going to put it all, shove it all into my string. I'm going to close up my file, and then I'm just going to print my string. And click accept. And now when we go ahead and say read crag, then we have the whole bunch of code all right here. Okay, so that's quick, easy, and a bit painless. All right, that's good. Now what else do we have coming up on the horn? I forgot what the next topic is. We have that. We have it reading. Okay, we have that good. Okay. Ooh, look at this. JSON. Okay. Now, a lot of times you're going to be using JSON files. Now, JSON is a file format that I'm relatively new. I've only been using it for about 10 years and so forth, but it's really actually a very cool and very dynamic thing. I used to be a kind of an XML person. Oh, we're going to show after this, but I've kind of like fallen in love with JSON just because it's so brutally simple. But anyway, JSON files are kind of like Python dictionaries. They're the embodiment of a Python dictionary put into one big old string and then outputted to a file. And if we were interested in learning more about JSON, then you could go over to the JSON website and blah, 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 blah. Okay. And then you can take a look at the whole document string of like what JSON is. But all of this schematical stuff really just translates into, it's a big, okay, no big deal. It's a dictionary. Okay, so let's take a look at what a JSON file might technically look like. So just like a dictionary, a Python dictionary, you'll see that it starts with curly brackets. And then inside of this, you have a key. In this case, we'll call a key scene objects, followed by a colon, and then the object. Now, for this, what we're doing is we're embedding a list of other dictionaries. So we have a dictionary composed of other dictionaries. You bet that's exactly what we're dealing with. And so what we have here is one object called scene objects. And then inside of scene objects are a whole bunch of children objects called scene object names. And here are these are the keys and these are the values associated with them. All right, how do we go about using this? Well, we have a script that you do this, and actually there is a JSON library that we can invoke from Python that will help us do all these things for us. All right, so the first step to do when you do this is we're going to import JSON. Okay, JSON is the library that we're going to need. And then same thing, step number 1, open the JSON file for reading. Step 2, we're going to read in that entire file of whatever is on there, and we're going to pack it all into just one object. We're going to call it file string, and then we're going to close the file. All right, good. Now, for for the simplicity's sake, I'm going to show you what the file looks like just as a brute raw string, because it could look like anything. And then from the JSON library, what we have here is a function called loads. What loads does is it converts a big giant string into a Python object, or in other words, it turns it into a dictionary for us. So isn't that nice of us? It does all that hard work for us. And so that's what we're going to do is we're going to translate that big giant mama string and we're going to transform it into a Python dictionary. And then what I'm going to do here, just to show you the difference, is I'm going to iterate through this dictionary, and then I'm going to look at all of the components inside of the dictionary, and then I'm going to output all of the other dictionary components here. So I'm going to click apply, and let's see what it looks like when we go ahead and read this. Let me give me some room here. All right. Hopefully you can see that. Okay. Now in this first part here, I did a direct dump from the string that I read in from the external file. And you see it looks kind of just like a dictionary. Okay, cool. And so what I did here was when I just went through and iterated through that dictionary and then printed out every one of its components. All right, so now we have it in a state that is usable, and this dictionary is very digestible, and then I can go and parse through all this data at my own leisure. Okay, now suppose if you wanted to write out the data. All right, suppose writing out the data. It's kind of the same situation, but kind of reversed. Now in this little file here, we're going to read in the data, but after we've read in the data, we're not going to bother writing it out. Let's just suppose you get done processing and you want to write out the data. Then instead of using loads to load or transform the string into a Python object, then you use the function or the method dumps. Dumps takes your object, takes your Python object, and then transforms it back into one big giant mama string. And so here we have is JSON.dumps, and here's our Python object. And what this does, and the rest of this where it puts indent for separator, these are optional parameters where they're not necessary. We can go in and add and jump these things depending on how much information you want to include. But what this does is it crams all that into one big giant string called object string. And then what I'm going to do here is just open up, well, three-step process again. Notice the pattern here. We open the file for writing, we write out our content, and then we close it again. So let's go ahead and apply this and execute it. And I don't think anything is going to output here. JSON.write. Okay, nothing outputted. So what it did was it read in the input, and then it quickly just digested it and wrote out the output again. So let's take a look at what this looks like. Okay, so here is what the object looks like after it's been written out back to JSON. Now, it looks like a very clean, very formalized dictionary. Well, that's cool, because that's exactly what we want, is something to look like a dictionary. Now, if we didn't put in all of this indent stuff, it would put it all into one big giant line. It's still a JSON file, but it just is a little bit harder to read. But it would still be okie dokie. Okay, now some of you may say, man, I don't dig on no JSON. I want to work with XML. Just give me XML. All right, XML is a little bit more difficult and a little bit easier at the same time. Okay, we've got our dumps. But when we're dealing with XML, what we're dealing is for a strictly hierarchical environment. And what we're dealing with are nodes, or they're called elements. An XML node or an XML element. And so we have one central XML element, and then it is composed of child elements. And those child elements might be consisting of other child elements, and it is very possible to have sibling elements that are both children of the same parent. Okay, now this is technically inside of an XML file how they're structured. Now they're typically followed by a less than little character followed by the word tag. Now you might have seen this before and didn't realize this was XML, but I'm explaining to you now. But inside of this open or this less than sign followed by a greater than sign, but in between there you might have a number of attributes, and they're typically of the format attribute equals value, and then there's just a space in between, and then you have another attribute and a value there. Now, this is terminated by another little kind of like a less than, but it has a forward slash tag and then a greater than sign. And so it's bookended by a tag and a slash tag. But in between there, you can have 0 or 1 text strings. That's it. 0 or 1 text strings. You can't have 2, you can't have 3, you can have 0 or 1 text strings. And you can have 0 or many other XML elements. So it's kind of recursive. So you can have multiple other XML elements embedded inside your initial XML elements. You know, you don't have to. You can have 0 or many, but those are the rules. And so with that, you can kind of create almost anything. Now, for those of you who are riggers out there, you're realizing, ooh, I can create a rig and output my rig hierarchy almost instantly with XML data. Yes, you can, and it works like stink on it. So let's take a look at a very simple XML string. Now, typically they have this little XML version thing that tells you what version of XML that you're using. Now, I've never seen anything but XML version 1, but XML is a format that is expandable so that you can have your own custom version of XML. But typically it looks like something that looks like this, where you have lots of little entries in here and you have these little one-line elements in here. Now, every one of these little things is an element. And you say, okay, well, what do we do with all these? This is all like gobbledygook. All right, now there are a lot of different Python libraries that will work with XMLs. Now, the one I like to use is one called etree, or it's called Element Tree. And it's got a simple parse function. What it does is it transforms all of the information into just attributes of one particular class, where you would have the tag information is put in the .tag attribute of the class. The parent information is a list of child nodes. So every single node is a list of child nodes. That's really all that it is. And then you have all your attributes are put in a dictionary associated with the class. And then if you have text information, then that's put in a text attribute. Okay, so every XML node contains either it has a list of other nodes, which is considered as children. It has a .tag, which contains a string component that covers the name of the actual node itself. You have the .attrib, which is the dictionary of all the node attributes. Then you have inside of that attribute, you have the key and the value, because it's a dictionary. And then you have the .text, which is the text element associated with the XML. Now, it doesn't have to have anything in there because the text element is optional in an XML node, but it is there in the .text information. All right, so let's take a look at some simple code that we have here. So let's take a look at an XML. And so here we have, oh, this is not what I wanted. I'm getting ahead of myself. XML in. Okay, now it's cool that etree does all the serialization, at least as far as reading information is concerned. And so the whole part about opening, reading, and then closing, etree takes care of that for us. We don't have to worry about it at all. So we just basically start with, we have to import the library. And then here I have this def function. We're not going to deal with that right now in a moment. So what we're going to do is first, so our tree is etree.parse countries.xml. So it's just one file that does all that stuff for us. And it's going to convert this file, countries.xml, and it's going to do all of its magic and convert it into a file structure for us that we can actually use, and then shove it all into this tree. And now tree becomes an object. It becomes the first node inside of this very large tree. And we're going to call that root. So that's why I say tree.getRoot equals root. And then what I'm going to do is that I'm going to recursively, remember we used recursion a couple weeks ago in order to explore rigs and other elements. Well, we're going to do the same thing here for an XML file, but we're going to recursively descend into an XML file and then list all of its elements. And that's what this function does. And so this function receives two parameters, the current parent, and an indent information. So we're going to keep track of how many generations it's gone into this thing, so we know how much to indent all the material. And so the first step of this XML, the first step of this recursive function is to just print out the node's values. And so we're going to print out its tag, we're going to print out its attributes, and we're going to print out its text information, if it has any. And then what we're going to do is we're going to explore all of its children. And we have a for child in parent. You're going to say, hey, wait a second. Parent, well, that's just me. How does child know when to do this? I didn't mention it, I didn't create it as any list. That's okay. Remember, when using eTree, every single node is a list. So it's kind of dual, it's got a dual purpose, and it's got an override, so it really translates. So it behaves, this node or this XML object is really a list. They're one and the same. And so what we're going to do is from this list of child objects, we're going to transform each one of those into a child, and then we're going to recursively call this explore XML node, and we're going to indent the generation by 1, just to make sure that our display is a little indented. All right, so when we execute this, this is what it looks like. And so you see here, we start off here at the root, where there's no information in here. And then we go here, and then we looked at the first country, which is Liechtenstein, and it has all this other XML data associated with it. And then the second country is Singapore, and it's got its data associated with it. Then Panama, and all so forth. And the information in each one of these countries is its own XML nodes in itself. So this actually works very, very well, and it's recursively really simple to create. It didn't create much here to print out that entire content. Okay, now what if you want to output this information? Well, things get a little bit squirrely when you want to output the XML information. Okay, then what you have to do is you have to use another library, another one of these XML libraries. And for this case, we're going to use the XML DOM, and we're going to import the mini DOM sublibrary from that. And ultimately, what I'm going to do in this file, I'm going to use Element Tree to just kind of create a little tree with A, B, C, D, and I'm going to the root is A, and then I want to make B and C its children, and then I want to make D something. And then what I have to do in order to convert all of that object into a string, what I have to do is I have to transform it into a string, and then I have to use the mini DOM to translate it into something that's nice looking. Because if we don't do that, if we don't transform it into something, it's going to put the XML file into one big giant long line, and it's going to be like unreadable. But that's what it's for, and it's called printing pretty. And that's why you see this too pretty XML. So what you're doing is you're imprinting and you're converting that one string into a pretty formatted XML document. Okay, and it's just inserting line strings into it. Okay, thank you very much. Well, once you converted it back into a string, then you go back into our traditional pattern of 1, 2, 3. First, you're going to open up the output. 2, you're going to write out the contents. And then 3, you're going to close it up. Nice and simple. So here we is, click apply. And let's go ahead and export this up. Say XML out. Okay, so let's take a look at the data. And here it is. Here we go. And so there it is. Now this is what outputted from eTree. So it created one big giant string with all this information with A as the parent, B and C as the children, and it created D as a child of C. Okay. So hopefully that kind of gives you a kind of a crash course for XML. XML stuff, there's lots of information and it's very robust. And it's a little bit more complicated to use, and it's very sophisticated. However, it does have its certain limitations. Now, JSON is brain dead easy to use, and it's super quick. And a lot of Python scripters and a lot of TAs use it because it's just so easy to remember, and there's very little to forget. It just said, okay, a JSON file is like a dictionary. Then that's all I'm going to have to worry about. All right, well, now that is all that I really wanted to cover today, at least as far as Python serialization is concerned. And so let's get things moving along here. All right, now I wanted to do is I want to bring up my document here. All right, okie dokie. Here we go. Okay. All right, so there we go. There's our XML stuff. All right, now that's what I wanted to show you today. So let's take a this. If you want to tune in today at 3 o'clock, what we're going to be dealing with Houdini Secrets Live, when we're going to be exploring rigid body dynamics, part 1. It turns out to be this is a very, very robust category, and it's going to take me a little bit longer to explore and to extrapolate to the rest of the ecosystem. So we're going to do it with part 1 today. And then can't meet next week. I'm going to be learning how to save my life if I ever get caught into an avalanche. And then the week after that, I'm going to be in Tennessee climbing on mountains. But so therefore, in 2 weeks, we'll be able to meet again for Tech Art Talk Live. That'll be on the 26th of March. And then we're going to do our last of our Python series, and we're going to be dealing with PyQt. All right, so if you like what you saw today, please go ahead, click that button down in that corner, and subscribe to this broadcast. And if you want to, check me out. I am Chris Rhoda. You can check me out on Facebook and on LinkedIn. And if you're interested, go ahead and check out TechArt.edu, which is kind of like the umbrella of this whole operation. You can see that on Facebook and on LinkedIn as well. Now, if you really want to help me, go on over to the TechArt.edu.com website. And if you see a little bit of click here now, you can go ahead and opt into our news service. And what we're going to do is I'm going to send you out updates. Yes, I know I said it again, but people are saying, oh, I don't want to get inundated with more emails, flood mails. I'm not doing a very good job of keeping everyone updated. But so I promise you the emails are going to be sparse, few and far between. And so I'm not going to inundate you too much. All right, well, anyway, check it into this and you'll get all of the information of all the shenanigans of what we're up to at TechArt.edu. All right, thank you very much for coming today. Thank you very much for enjoying this exploration of Python serialization. And I look forward to sharing PyQt with you again in 2 weeks. So until that time, I'll talk to you later. Have a great week.